All right, 23. For the same signal emitted by a radio antenna, observer A measured its intensity to be 16 times the intensity measured by observer B. The distance of the observer A from radio antenna is what fraction of the distance of observer B from the radio antenna? Okay, so first let's bring up the equation that we have. Okay, so we go back up here. See that the equation is I equal to P over 4 pi r squared, right? And P is a powerized intensity. R represent the distance, okay, away from the antenna. Okay. So here they told us we had two observers, and observer A's intensity is 16 times stronger than observer B. And we think about this, the radio antenna is a point in the middle, right? And as we get closer to the source, then it should be a stronger signal, right? As we get further away, right, the signal will get less and less strong as we get further away. So if observer A has a higher intensity, then it should be closer to the source. Okay, but if you look at the answer to it, they all have like a fraction, right? So yeah, so they all kind of make sense because fraction less than 1. So it means it's a fraction of a distance compared to observer B. Okay, but then how do we figure out the exact number? Right, what we can think about is this. So if the intensity had to be 16 times stronger, so pretty much it used to be I, right? But now it should be 16 times stronger. So we want the intensity to go from I to 16I pretty much, right? So pretty much this whole thing have to multiply by 16, right? Because that's what represents the intensity. So we want the intensity to be 16 times stronger. This fraction here, the P over 4 pi r squared have to be 16 times bigger. Okay, so what we're trying to do pretty much is we're trying to figure out how can we change the R value so that this whole thing will come out to be 16 times bigger. Okay, and we know P is going to stay the same. Okay, that doesn't change. And then 4 pi, they are numbers, so they will stay the same. So the only thing that we're changing here is r squared. Okay, it's an r value, but don't forget that will be squared. Okay, so if you plug in 1/4 for the radius, okay, so instead of r, if it's like 1/4 r, so everything else will be the same, right? The only difference here is instead of r, we get 1/4 r, and this whole thing is squared. Will that make this 16 times bigger? Well, if you solve that, right, so everything, the constant we don't have to worry about, but the 1/4 r, we had to square that. So we do have to square the 1/4 as well. So 1/4 squared will be, so I had to square the top and the bottom. So it'll be 1 over 16 r squared. Okay, so 1/4 times 1/4 is 1 over 16 r squared. And see what happens is the 1/16 is on the bottom. So we're dividing by 1 over 16. So this is the same as P over 4 pi r squared. Dividing by 1 over 16 is same as multiplying by the reciprocal. So it is same as times 16 over 1, which is times 16. Okay. And see, that's actually what we want, right? We want this here, this represent intensity, and we want it to be 16 times stronger. So we want to multiply by 16, and then A will actually give us that. Okay. So that should be our answer. All right. So what happens, the 1/4, so at the first is r squared. So that's how we get the 16. 1 over 4 squared is 1 over 16. And then we're dividing by 1 over 16 is same as multiplying by 16. Okay, so that's why it is A for our answer. If you do the other answer choices, after we square them, the number will be too big. Okay, so it won't be times 16, it will be a much bigger number. So that's why it's not B, C, and D here. Okay, so that's it for number 23. So for a question like this, We had to think about whether if we had to square the number. And then also if we're dividing by a fraction, we had to flip it and multiply by the reciprocal. Okay, so that should be the answer for 23.